This lesson is an introduction to problem solving by dimensional analysis in chemistry. The steps to problem solving involve to analyze the problem. You want to identify the unknown. What is it that you're trying to find out? And you want to identify the knowns. What information are you given? You want to plan the solution. Is really how do I get from the knowns to the unknown? And then of course you want to do the calculations and check your solution to make sure that you have done everything correctly. Again, this is going to involve dimensional analysis. This is the use of units or dimensions to organize and solve the problem. This is going to be used extensively in chemistry, and it's not something you can just learn once then forget. You'll be using it continually, and it has many applications in virtually every area of life that involves numbers. It involves converting from one unit to another unit. It involves multiplying by an equivalent, something that is equivalent to 1 to get the same value, only in a different unit. The simplest sequence I can give you to help you understand what dimension analysis involves is this. Anything times itself is itself. So if I take a certain number n, multiply it by 1, I get the same number. The number 1 can be expressed as 1, or it can be expressed as any ratio that is equivalent to 1, such as 1 over 1, or 5 over 5, or 1 dozen and 12 eggs. 1 dozen is the same as 12 eggs, so this ratio, 1 dozen over 12 eggs, really is 1. And then if we throw a number in there for n, if we have 36 eggs, we're going to multiply 36 times 1, divide it by 12, which is going to give us 3 dozen. So 36 eggs and 3 dozen are really the same amount of eggs. It's just now we're expressing it in dozen instead of eggs. So note eggs are on top here, eggs are on bottom, so they cancel. Always the unit that you want to cancel out or the unit that you start with. Okay, let's convert between inches and centimeters as an example of dimension analysis. So if I gave you the problem, how many inches are there in 23.5 centimeters? The unknown is inches, so that's what I want to find out. My known is 23.5, that's my given or my known. The conversion factor is the plan. How do I get from my known to my unknown? Well, here's the mathematical equivalent. 1 inch is equivalent to 2.54 centimeters. So I take my known, write it outside my equivalent, my set of parentheses, and then I've got to arrange my conversion factor so that centimeters are going to cancel. So I want to take the 2.54 centimeter value, put it on bottom, so centimeters and centimeters will cancel out. The unit I want to convert into, I'm going to put on top, and so really we're going to multiply 23.5 times 1 and then divide by 2.54, which is going to give us 9.25 inches. If we use the same units, but we convert in the other direction, say for now the unknown is centimeters instead of inches, my known is inches instead of centimeters. So now we're converting the other direction from inches into centimeters rather than from centimeters into inches. Now my, again, known inches goes on the outside, and now my inch is going to go on the top. The 2.54, inch is going to go on bottom. 2.54 centimeters is going to go on top. And that way inches and inches are going to cancel. So now I'm just going to multiply 36 times 2.54, which is going to give me 91.4 centimeters. Okay, what if I want to convert between meters and kilometers? So how many meters are there in 12.5 kilometers? So now I take my 12.5 kilometers, my known, I'll write it out here. Now I want to put in my equivalent units, and if I want to find meters, they're going to go on top, and the kilometers are going to go on bottom, so that's numerical equivalent. 1,000 meters equals 1 kilometer. Now kilometers are going to cancel. 12.5 times 1,000 is going to give me 12,500 meters. And if I want to go the other way, if I'm starting with meters and I want to find kilometers, now my meters are going to go on bottom, My kilometers are going to go on top. Now the meters and meters cancel, and now I'm going to divide by the 1,000. So it's 1,110 divided by 1,000, and that's going to give me 1.1100 kilometers. So again, always the equivalent is equal to 1. This is a ratio equal to 1. This is a ratio equal to 1. But I arranged the units or the dimensions, so the dimension I'm starting with will cancel out, and I convert to the dimension that I want. How many atoms are there in 12 moles of carbon? So my known is 12 moles of carbon. My unknown is atoms. So I write down my 12.00 moles. Here the equivalent is 1 mole equals 6.02 times 10 to the 23rd atoms, or what we call Avogadro's number. So we're starting with moles. So we want to put the mole on bottom. We want to put Avogadro's number on top. Again, that way moles and moles cancels, and 12 times Avogadro's number gives me 7.22 times 10 to the 24th. Next problem, again, note it's the same units. It's converting between moles and particles. And so now we want to use the same equivalent. 1 mole equals Avogadro's number. So now we want 1 mole on top, because that's what we want to find out is how many moles. And we want Avogadro's number on bottom. So now we're going to divide by Avogadro's number. When you divide by Avogadro's number, be sure you put it in parentheses, and that'll come out to 7.97 moles. Okay, this is a two-step problem. How many oxygen atoms are there in 4.6 moles of aluminum nitrate? So my unknown is oxygen atoms. How many oxygen atoms? And there's 4.6 moles, so that's my given. And the conversion factors, for every 1 mole, there's Avogadro's number. And for every 1 unit formula, every 1 chemical formula of aluminum nitrate, there's going to be 9 oxygen atoms. 3 times 3 is going to give me 9. So we want to go from moles to unit formulas, and then from unit formulas to atoms. And so we're starting with moles over here. So we want the mole unit on the bottom here, and Avogadro's number of unit formulas on top. And then that way moles and moles are going to cancel. Now we've got to get rid of unit formulas. So we want to put 1 unit formula on the bottom, so unit formulas cancel. And that is equivalent to 9 oxygen atoms. So the math is going to be 4.6 times 6.02 times 10 to the 23rd times 9, which is going to give us 2.5 times 10 to the 25th oxygen atoms. But again, note how the units cancel. If moles are outside here, bottom here. If unit formulas are on top here, we want unit formulas on bottom here. The only unit left uncanceled is oxygen atoms, top right, and that's what we want to find out. Here's a more complex problem. Now we've got a ratio. I want to convert 5.0 miles per hour into feet per second. So I've got a ratio miles to hour, and I want to change that to feet per second. So I've got a distance unit to change and a time unit to change. And so my unknown is feet per second, given is miles per hour. Here we need a conversion factor for my distance, and so 1 mile equals 5,280 feet. I need a conversion factor for my time units, and so 1 hour equals 3,600 seconds. Writing it this way, the ratio is miles per hour. And so now I want the 1 mile on bottom, so miles and miles will cancel. I want the 5,280 feet on top, and then note hours are on the bottom here, and so I want to put my hour unit on top here, so they will cancel out. And then the 3,600 seconds is going to go on the bottom here. And note I am ending up with feet over seconds. All the other units cancel. That's what I wanted to find out, was feet over seconds. And so it's going to be 5 times 5,280 divided by 3,600. Hope this helps.